So Google's put out a new paper called AlphaEvolve, and the results of this paper are extremely impressive. It discovered novel, state of the art solutions to problems such as 4x4 matrix multiplication and bin packing, and it's found new algorithms to optimize Google's compute budget. There's one quote that people are latching onto, which is this deployment marks a novel instance where Gemini, through the capabilities of AlphaEvolve, optimizes its own training process. Now, this is a little bit scarier than it sounds. It didn't like it's not like it trained itself. It did come up with improvements to kernel efficiency on TPUs. So, right, they improved their tiling of multiplex multiplication on TPUs. They claim a 23% speed up. There's also something interesting about flash attention. They claim a 32% speed up on their flash attention implementation on TPUs, which is pretty cool. So, lots of really impressive results. On the other hand, I don't actually find it super theoretically interesting. And I also think the word evolve here is kind of a weak use of this term, right? Basically, they take a frozen language model and they do not continue training it at all. There's no training. So this is the opposite of things like O3, DeepSeek's R1, and all of these reinforcement learning methods. They don't do any of that stuff. There's like, the LLM's frozen, we don't touch it. We just sample from it, just like you could on the public API. So it's really just a harness around an LLM, where you sample from the LLM, you take your solutions, you evaluate them, you put them in a database, you pick some solutions, you add them to the prompt, you iterate. You could kind of see this as kind of like Monte Carlo tree search around an LLM, a little bit. They do have a small amount of crossover. So you could say this is like a mini genetic algorithm, which is kind of where they get the evolution. They're like, this is an evolutionary algorithm. You know, you could claim, I don't find the crossover argument super strong. This is from their previous paper, Fun Search, which is the predecessor. You can see in this image that like, I don't know, they like make separate subpopulations, which is like the different behaviors, and then they keep all of them separate, and then they just kind of like take one high performer from a subpopulation and reset it to a new island. You know, it's like they don't really have like migration. They don't, it doesn't feel like that strong a claim of like the genetic algorithm aspect. It's unclear to me whether this is so much better than MCTS, but there you have it. So the way I see it is like, you know, somewhere between MCTS and a genetic algorithm, but really it's a frozen LLM in a harness. And I just don't have a lot of faith in the research direction of keeping the LLM frozen. We've just seen such unbelievable things come from keeping the gradients flowing. I think RL has been incredible. And really, you could think of this whole process as like doing some out of distribution sampling, right? Like this thing that they're doing, this LM in a loop making distro programs, this is not the distribution of the training data. They're taking the training data and they are coming up with new tasks that it was not trained on. So it's like, you know, what can you really expect from out of distribution? Maybe you're lucky, and it seems like they were lucky enough to, when you throw it in an MCTS, solve all these great problems. Like good for you, happy for you. But on the other hand, it's like, I don't know, wouldn't you want to use RL to like re-optimize against the task at hand? Like, where's your adaptation to the present task? So I think it's really cool, the results, but this seems to me very unlikely to have, you know, stacked gains. I think it's much more likely that we're going to have the next generation of either pre-trained LLMs or realistically RL. And then this team will just like make the same scaffold or harness, which I'm just going to call MCTS, even though they call evolutionary, you know. they also just like they don't have any detail. I find this so frustrating. This is the whole section on the evolution, which is the whole algorithm. The whole algorithm's evolution. This is all they say. During the evolutionary procedure, it generates candidates, stores them in a database. Difficult to balance exploration exploitation. You know, oh, we kind of are inspired by Maps Elite and island-based population models. It's like, we kind of Maps Elite isn't that interesting. It's just like define some features and then just say like, okay, so we're going to need to have diversity across these features, separate them all into cells by where they fall across each of these discretized features, and then like make sure you keep optimizing in each cell, or like keep your diversity across cells. So it's kind of like an artificial creation of diversity based on some metrics. And then island-based population, that's kind of what I was saying before, where it's like you have separate islands and they like don't really interact. So you have kind of these local dynamics, but not these global dynamics. But it's like, I don't know, like what the fuck did they actually do? It's one sentence, right? So another paper where they don't tell you what they did, they just kind of like tell you the results and they're impressive, but what's super clear is they froze the weights. And I think that's really important to understand because a lot of people misunderstood this. A lot of people are really getting confused about the fact that like reinforcement learning is a gradient-based technique. This is a gradient-free technique. So, I don't know. I mean, the results are cool. A lot of people like to put LLMs in harnesses, LLMs in loops, LLMs in tree search, candidate generation, candidate improvement. These are classic concepts. But at the end of the day, like, come on, if you're not messing with the gradients, it's just like, gradient-based techniques are astounding, truly astounding. And even something like RLHF is astounding in its power. But on the other hand, very cool results. This seems like a pretty damn good harness. As harnesses go, like look at the things they've solved. So, very, very cool coming out of Google. And it's good to see that we have some gradient-free techniques like this one. And then we have a lot of interesting work coming out of the gradient-based techniques, which is basically all of RL. I'm obviously a big fan of the RL side, but it's good to have both. We'll see how it turns out.